Objectives for Rule 1.7. Number 1, use interval notation. Number 2, find intersections and unions of intervals. Solving linear inequalities. Recognizing inequalities with no solution or all real numbers as solutions. Solving compound inequalities. And solving absolute value inequalities. You see the theme for today? Mostly inequalities, right? Okay. So let's start off with interval notation before we can get to inequalities, okay? So if I tell you the inequality is x is greater than 12, I need you to be able to tell me the interval notation. Okay? If it's everything greater than 12, where does it start? 12, and it goes to where? Infinity. Is 12 included as part of my interval? No, because it's just greater than, so I put a parenthesis. And a parenthesis always goes around infinity. Do you remember why? Do you know where the end of infinity is? Neither do I. Okay? On a graph, it would look like this. Here's 0, here's 12. I got to actually show you two ways to graph this. The way that you're used to and the way that the book sometimes does it. Okay? You ready? Which way are you used to? What goes on the 12? Open circle. And which way do I shade? To the right. Everybody okay with that one? Here's how they'll do it, not only in this book, but in some upper level math classes as well. Okay? Instead of an open circle, what goes around the 12 right here? A parenthesis, so they actually put a parenthesis right on the graph. Does that make sense? Okay? What about if it's x is greater than or equal to 12? What's the interval notation look like here? Still 12 to infinity, right? But what goes around the 12 this time? A bracket, right? Because 12 is included because it's greater than or equal to 12. So this time on the number line, making sure we know both ways, it would either be a closed circle on 12, pointing greater than, or an actual bracket, pointing greater than. Everybody understand that okay? Okay. Two is less than or equal to x is less than 4. What does this look like in interval notation? Where does it start? 2. And where does it go to? 4. What goes around the 2? Bracket, how do you know? Or equal to, right? And what goes around the 4? Parenthesis, because it's not or equal to. So if we're doing dots and open dots, closed dots and open dots, what goes where? Closed dot on 2, open dot on 4, and then we shade in between, right? Like that. What if we're doing parentheses and brackets? What goes where? Bracket on 2, parenthesis on 4, and I still shade in between, don't I? Any questions about that? Do you need any more examples of that, or is that good? That's good? Okay. So how comfortable are you with interval notation? Remember that stuff? Excellent. Intersections and unions. There was some intersections and union questions on your chapter P, but that's not something we talked about in Algebra 2, is it? We talked about different sets of numbers and how they relate, but we didn't ever use the notation of intersections and unions. Okay? So I need to make sure that you understand this. So first of all, this upside down U, like a frowny face, is an intersection. Okay? This means it has to be where they both live. Okay? Sometimes the easiest way for people to see this is on a number line. So can I draw some number lines for you? Okay. You won't always need a number line, but just to start out. 1, 2, 3, 4, 5, 6, 7, 8. 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the first one, 1 to 4. What does that look like? Or parentheses, right? 1, 2, 3, 4. 1 to 4. You see that right there? Yeah? What does 2 to 8 look like? So bracket on the 2 and bracket on the 8, right? Now, it has to be where they both are, which is just right there, right? So just from 2 to 4. Everybody understand that? It's just from 2 to 4. Now, is 2 included? Well, it's included right here, and it for sure is included right here, so the 2 is included here. What about the 4? It's included here, but not here, so we can't include it on the answer. Everybody okay so far on intersections? Okay. Now we absolutely use the union symbol in Algebra 2, especially when we were talking about multiple parts of a domain. Remember using that symbol? So the union, sorry, let me write union. The union symbol means one or the other or both. One, 2, 3, 4, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 1 to 4 looks like this. 1, 2, 3, 4. Looks like that. 2 to 8 looks like this. Oh, dang it. I put it on the wrong one. Ignore this one then. Sorry. So one or the other or both is that, isn't it? So is 1 included as part of the answer? It's not here. and it definitely isn't here, so I can't include it as part of my answer there. Is 8 included as part of my answer? Yes, so I include it as part of this answer. And 2 is included, 3 is included, 4 is there, 5, 6, 7, 8 is all there, right? So it's everything in between. So it goes from 1 to 8. What do you think? How do you feel about unions and intersections? Any questions on them? All right, you ready for some linear inequalities? Now you look at that and say, oh man, that's super, super easy, right? Well, it is, right? Isn't it? What's really the only thing we have to be careful of? When we divide by a negative or multiply by a negative term, we have to flip the inequality sign, right? That's the main thing that we have to be careful of. When we multiply or divide by a negative number, we have to flip the inequality sign. And remember, when we do solve linear inequalities, part of our answer is the number line. Okay? Is negative 4 included as part of my solution? So I got a bracket, and it's greater than or equal to negative 4, so I shade to the right. Okay, with that one? Do I need to do a whole lot of those for you? You got those, right? Okay. Well, what about this one? X plus 5 is less than x minus 4. When I subtract x from both sides, 5 is less than negative 4. What? Yeah, no, it's not. Is it? Did I do anything wrong? Then what's this answer? No solution. And if you'll remember, part of our objectives were recognizing inequalities with no solution or all real numbers as solutions, right? So that's an easy way to tell if it's no solution or if it's in all real numbers. Look at it. Is 5 less than negative 4? No. There's no value of x that I could put in that will make that true. So the answer is no solution. X minus 4 is less than x plus 5. What about this one? When I subtract x from both sides this time, I get negative 4 is less than 5. Is negative 4 less than 5? Will negative 4 always be less than 5? So, good. Do you see how you can tell the difference? It's basically just, is it true or not? Okay? Compound inequalities. We kind of did this in Algebra 2. We didn't really call them compound inequalities. Can I show you what I'm talking about? Negative 3 is less than 2x plus 1. And 2x plus 1 is less than or equal to 3. Remember doing and or statements? That's what we called them. That's what our book called them. This book calls them compound inequalities. That's what they really are called. Okay? Well, it just means I solve this one and then I solve this one. That's all it means. Okay? So minus 1 minus 1. Negative 4 is less than 2x. Divide both sides by 2. X is greater than negative 2. And then I go to the other side and solve the other one. Minus 1 minus 1. 2x is less than or equal to 2. Divide both sides by 2. X is less than or equal to 1. Because it's an and statement, what should happen to the shaded area? It should be between. Yeah. Okay, it should be between the two numbers. Okay, so I've got my number line right here. I've got negative 2 here, and I've got 1 here. What goes on the negative 2? A parenthesis or an open circle, right? And what goes on the 1? A bracket. And I know it's an and statement because it literally says and in it. So I know I shade between. But if I didn't remember that, think about it this way. X is greater than negative 2, I'd shade to the right. X is less than or equal to 1, I'd shade to the left. Isn't that in between the two? Yeah. You okay with that? Then there's ones that look like this. That's definitely a compound inequality because there's more than one inequality symbol in the problem, right? So this time when I subtract 1, I have to subtract 1 from every side. Normally we say both sides, right? Except now there's 3 sides. Do you see that? One side here, one side in the middle, and then one side over here. This is negative 4. This is 2x. This is 2. Now what happens when I divide by 2? Divide everything by 2, right? So negative 2 is less than x is less than or equal to 1. Guys, do you recognize it's exactly the same problem that we just did? Okay? This one is just written as an and statement, and this one's written more as a compound inequality, even though they're both compound inequalities. Does that make sense? Okay. And then, of course, we have the graph. It's part of our answer. But since I just told you it looks exactly the same, you don't really need to draw it unless you just want to, because it's literally exactly the same as the one we just did. How do you feel about compound inequalities? Good? Okay, good. See a lot of thumbs up. That's excellent. Last thing is absolute value inequalities. Okay? Absolute value inequalities, if you'll remember, we worked on these quite a bit, but right at the beginning of school. So it's been quite a bit since you've seen these. Okay? Some things I want to show you before we just go willy-nilly into this. First of all, anytime there's a negative number on one side of the equal sign, that should get your spidey sense going. Okay? Now, not so much on this problem because I haven't isolated my absolute value yet, right? Can't really do anything till the absolute value is isolated, but maybe a little spidey sense to show that you're paying attention. Okay? What do I do first? Because the goal right now is to isolate the absolute value, right? And now what? Good. Divide both sides by negative 2. 3x plus 5. Oh, excellent. Why is it less than or equal to? I divided by a negative, so I had to flip my inequality sign. Okay? And 10. So, just so we have a running reminder of our steps. First, I have to isolate the absolute value. You remember that? Once it's isolated, what do I do now? I got to make it to go into two parts. The first part is whatever's inside is exactly what it is. It's the positive whatever's inside. So in this case, 3x plus 5. I put 3x plus 5. What if this said 3x minus 5? What would I put right here? 3x minus 5. Exactly what it said inside the absolute value. Okay, that's just its positive value. Even if it says minus 5, you bring down a minus 5. Okay? And then what's the other one? What's the other part? The negative of whatever was inside. Okay? Whatever was inside, I bring it down exactly as it was. Whatever's inside, I bring it down and then multiply it by a negative. Okay? So now solve each part. Solve each side or each part. Okay? Because now it's like a compound inequality, right? So subtract 5 from both sides. 3x is less than or equal to 5. Dividing both sides by 3 gives me x is less than or equal to 5/3. What about over here? So we could distribute, right? A lot of people like to not distribute. They actually like to divide by -1 first. Do you remember why they like to divide by -1 first? Are you more likely to remember to flip this sign at the very beginning of the problem or at the very end? Most people are more likely at the very beginning because that's still in their range of knowledge, right? Of thinking. Subtract 5. 3x is greater than or equal to -15. Dividing both sides by 3. X is greater than or equal to -5. So I've got -5 over here. I've got 5/3 here. And I realize what goes on the 5/3? A bracket. What goes on the -5? Oh, dang, I put it on the wrong side. It's still a bracket though, right? Sorry. 5/3 is first. -5 is second. It's less than 5/3 and it's greater than 5. So what kind of statement was this? That's an and statement, right? Since it's an and statement, I can write my answer as -5 is less than or equal to x is less than or equal to 5/3. Questions? One more? No? You good? All right. How do you feel about all these objectives for today? Fairly confident? And if you're not, what can you do? Always ask, right? You can always ask. Okay?